Let's jump into our notes. Here we go. All right, so like I said, here we are at the end of week 6. So after this, we've got 2 classes in week 7 and 1 class in week 8, and then we will be all done with the year. So today we're going to be talking about density. Density is another kind of measurement similar to mass and volume and length that we were just talking about. But it's a little bit more complex. It's actually, as we'll see in a little bit, it's actually a combination of mass and volume. So it's a comparison of how heavy something is to how big something is. So today we'll talk about what makes something more dense versus less dense. We'll talk about how do objects interact when their densities are different. And we'll talk a lot about how to calculate the density of an object. It's something that you can't really measure with a ruler or a scale on its own. It's something you have to do a really, really simple little math problem in order to figure out. So let's talk about density. Hey, Shannon, good to see you. Thanks for jumping on with us. All righty. Let's see, where's my mouse? There's my mouse. Hey. So, like I was saying a second ago, density is not directly how heavy or how big that something is. Instead, it's a measurement of something that we could call compactness. So how compact, how crunched together this piece of matter is. So it essentially is a measurement of how close the atoms or molecules are to each other. The closer that they get, the more atoms and molecules that you can cram into a small space, the more dense that your object is. Again, it's not just heaviness, right? Sure, some things are really heavy, but if they're ginormous, like, I don't know, a refrigerator, right? Pretty heavy. It's really hard to move one by yourself. But a refrigerator is also really big. And so just because something is heavy, that is not what makes it dense. Density also includes how much space an object takes up, right? So if something is really small and heavy, like a 50-pound weight that you pick up off the floor, right? That's not super big and it's really heavy. So that weight would be really, really dense. Whereas something like a refrigerator, which is very heavy, but it's also very big, it's a very large structure, that might not be as dense. Sure, it's heavier than that 50-pound weight, but it also is a lot bigger. So density, again, is not just heaviness. That's the one thing that people kind of get confused about, is that it's related to heaviness, it's related to weight and mass, but that's not the only thing that goes into it. It also depends on how much space an object takes up, the volume of an object. So all matter has density. So liquids and solids have density. That's kind of pretty easy to think about. But so do gases. So even gases can be more dense or less dense. So the way that I kind of like to think about density is, imagine your kitchen trash can at home, right? I can imagine it pretty easily because today was my trash day. I had to take all my trash out last night and put the bins out by the road. So your kitchen trash can, it starts to fill up with some different stuff that you're cooking or packages that you're eating out of or whatever it is. And once that trash makes it to the top of the trash bin, nobody just immediately throws the trash out, right? Instead, what you do is you take your hand or you take a shoe or a paper towel or something and you squish it down back in there. And you're able to make some more space, right? So you had all this trash, but then you squished it down to the bottom so that you could add more trash. So at first, that stuff started as not very compact. It was all just kind of loose and sitting together in your trash can. But then you compacted it down to add more trash. And when you did that, you made your trash more compact, more dense. So there's more trash in the same size trash can, right? You still had the same plastic trash can that you were putting stuff in, but you squished down the old trash and added new trash in on top. So you made your trash more dense. So again, if you start off with stuff that is kind of loose, kind of separated from one another, this is not very compact. This is a little bit spaced out, a little bit loose. Kind of these particles are like kind of flowing around one another. But if you squish them all together and force them all close into each other, then you get a much more compact material, right? So these particles up here are less dense, and these ones down here are more dense, more compact, more closely squished together. Just like with your trash, if it starts out all kind of just sitting on top of one another and still like full-size bags and stuff, that's not very compact. But if you squish it down, if you smush all that trash in together, try and get as much use out of your trash can as you can, then you're going to get a more compact set of trash, more compact, more density in your trash can. So the kind of scientific way to describe density is the amount of matter per unit volume, which is just a fancy way of saying the mass, the weight, compared to the volume, the size. So it's this ratio of mass to volume. It's this comparison of how heavy something is versus how big something is. So if something stays the same size, if the volume stays the same, but the mass goes up, then the density will increase. So this is exactly like that trash example that we were talking about earlier. Your plastic trash bin, right? Your trash can stays the same size, but you added more and more and more trash in there. You increased the weight or the mass of the trash. You increased the amount of trash in your trash can. So when you did that, the density went up. You had more stuff crammed into this small trash can. On the flip side, if you are at like an apartment or something and you have to dump your trash out in the dumpster, let's say instead of tying it up in the trash bag, you just take your trash can out and empty your trash can straight into the dumpster. So the mass stays the same. You have the same amount of trash in your trash can and in the dumpster, but the volume went up. Now your trash went from your little trash can in your house to this huge dumpster in your apartment's parking lot. So in this case, the density is going to go down. There's the same amount of stuff, but it's in a much bigger area now. It's in a much larger volume of space. So if the amount of space and the amount of size goes up and you have the same amount of stuff, the same mass, then the volume goes down. So if your mass stays the same, then when the volume goes up, the density goes down, because now it has more space. It's less compacted in and squished together. It can spread out and take up a whole bunch of space in our dumpster. All right, so it's all about comparing this mass to volume. If the volume stays the same, if the mass goes up, the density will go up. If the mass goes down, the density will go down, right? If you take some trash out of your trash can, then you're going to decrease the density of that trash. And then like we were just saying, if the mass stays the same, if you have the same amount of stuff, if the volume goes up, if you spread it out, now it's less compact and you have less density. Or if the volume goes down, if you put it in a smaller trash can and squish everything really, really tight and together to fit in that smaller space, then the density is going to go up, because now you have the same amount of stuff, but it's been squished even closer together in a smaller bag or a smaller can. So density, all about comparing the amount of matter or how heavy that something is to the volume, comparing it to how much space it takes up. If you have something that's really heavy in a really small space, you have a very dense object. If you have something that's pretty light and it's in a really big space, that means that you have a relatively low density. All right, so we'll talk a little bit more about density and mass and volume here in just a second. But does anybody have any questions so far? Anything about density that you're a little bit confused about, or the trash example that didn't make a whole lot of sense? Please let me know.
I'm good.
All right, cool. Thanks, Ruben. Shannon's got it too. Awesome, awesome. So density, all about comparing mass and volume. And so we can actually calculate the density of different objects. Every single solid, liquid, gas object on Earth has a specific density. And if you know a little bit of information about that object, then the density is actually pretty easy to calculate. So our density equation, D density is equal to mass divided by volume. So if you know how heavy that something is, and you know how much space that something takes up, you can calculate the density of that object. So mass divided by volume. Usually the mass is expressed in grams. So again, G for grams, like we were talking about yesterday, one of our base units. And then volume is usually expressed in centimeters cubed, which is that kind of weird solid volume measurement that we talked about the other day. Or sometimes it's in like milliliters and liters as well. The actual unit of measurement doesn't really matter all too much. Again, as long as you know what the mass is and you know what the volume is, then you can do this simple little example or simple little equation to figure out the density of your object. So, for example, let's say that your trash can had a volume of 100 cubic centimeters. So your volume of 100 cubic centimeters, and you take your trash out of your trash can and you measure it, and it has a weight of 500 grams, let's say. So our mass is 500, our volume is 100. So to find the density of our trash, we could do mass divided by volume, or 500 divided by 100. And that would give us a density of 5. 5 grams per centimeter cubed is the density of your trash.
Can you do that one more time? Can you say that one
Sure.
more time?
So the one annoying thing about this is I don't think I can write on the thing. Yeah, so I'll also put those numbers in chat if it's easier to follow along there. So let's say the volume of your trash can is 100 cubic centimeters. And you take your trash bag out and you measure the mass. And the mass of your trash can is, I don't know, 500 grams. So if our volume is 100 and our mass is 500, in order
0.2.
close, you got them switched around.
Switch.
Yeah, that's what I came up with. That's why I asked you
Is-
again, because that's what I came up with in the calculator. So I don't. I'm trying to figure out how.
The tricky thing is you got to pay attention to which one is which. So I told you the volume is 100. So the volume is going to go on the bottom of your division. The mass, 500, is going to go up top. So density is equal to mass divided by volume.
Yes, 5.
Is equal to 500 grams divided by 100 centimeters cubed, which is 5 grams per centimeter cubed.
Ah, okay. I got it.
So mass divided by volume. If you're ever calculating density, whatever number is your mass, you do that first, and then divide, and then whatever number is your volume, you do that second. So yeah, I gave it to you that way because for your homework and assignments for today and tomorrow, you'll be doing some basic density questions. And sometimes they'll give you the mass first and then the volume. But sometimes they'll give you the volume first and then they'll give you the mass. So it's up to you guys to figure out which one of these is my mass and which one is my volume. And then do the mass first and the volume second. Density equals mass divided by volume, grams per centimeter cubed, or sometimes grams per milliliter or kilograms per liter. The units themselves don't really matter. What matters is figuring out what's your mass and what's your volume. So that is sort of our base density equation. If we want to know density, then we can do this simple little equation and figure out what it is if we know the mass and we know the volume. So the other nice thing about this density equation is that if we need to, we can move some of these numbers around in order to figure out some of these different variables. So here is our basic density equation. D equals mass over volume. Sometimes you'll also see it written out as density, or D equals M over V. But based on this equation here, we can do a little bit of basic algebra, move some of these around, and also figure out some of these other variables as well. So, for example, if you knew what the volume, or you knew what the mass of your material was, and you knew what the density was, you could figure out the volume. So if we go off of that example we were looking at earlier, if we know that our mass is equal to 500 and our density is equal to 5, then we can do volume equals the mass of 500 divided by the density of 5. And that will give us a volume of 100. So if you know the mass and you know the density and you want to figure out the volume, you can do mass divided by density to find volume. This also works for our third variable here, mass. Mass is a little bit different because with mass, you're not going to do a division, you're going to do a multiplication. So mass, the weight of an object, is equal to density times volume. So the way this would work is that if you knew that your density is 5, and if you knew that your volume is 100, and mass would equal to density 5 times volume 100, would give you a mass of 500. Again, as long as you know 2 of these numbers, you can do one of these equations to figure out the third one. One way that people sometimes find is helpful is using what's called the DMV triangle, the density, mass, volume triangle. And the way this triangle works is that you cover up you kind of block out the one that you're looking for, and the triangle will tell you how to do the equation to find it. For example, if we're looking for density, if we block out the D over here, we're just left with the M and the V. And the triangle says that M is above V, so you do M divided by V, and that's what will give you your density. Mass divided by volume gives you density. Same thing for volume. If you want to know the volume, you can block out the V, and you're left with M, which is over the D. So to find volume, the triangle says you do M over D, or mass divided by density, in order to calculate the volume. And then finally, if you want to know the mass, you can block out the M, and you're left over with D and V, which are down here next to each other together. And that means that you multiply them. So mass is equal to D times V. If you want to know the mass, the D and the V are down here together. So D times V is what is equal to mass. Density times volume is mass. So we start off with our basic density equation, right? Density equals mass divided by volume. But if we know any of the other two numbers, so if we know what the mass and the density are, or we know what the density and the volume are, we can do a simple equation to either tell us what is the volume if we know the mass and the density, or what is the mass if we know the density and the volume. So all three of these guys are all related to each other. And if you know the numbers for two of them, then you can always calculate the third one.
And it cannot be changed, right? Like the mass is always on top of the square.
Yep. So if you're doing your DMV triangle, you're always going to have the mass on the top and the D and the V on the bottom. That way you always know that if you have the mass and you have the D or you have the V, you'll always do mass divided by V or mass divided by D. Mass divided by volume to get density, and mass divided by density to get volume.
Got it.
D and V, because they're being multiplied, it doesn't really matter which side of the triangle that they go on, but the M will always be up at the top of the triangle. All right, good question there. Anybody else have any questions? Anything about these three equations that you're still a little confused about, a little unsure on?
I'm fine.
Right. So that is probably the most important thing that I wanted to get across to you guys about density today, is just related to the density equation, comparing the mass and the volume of an object, and how you can use either one of these three equations to find your unknown variable, whether you want to know density or you want to know volume or you want to know mass. As long as you know what the other two numbers are, you can do one of these equations to find out the third one. All right. So up next, I'm going to go over just kind of some basic ideas of how density works in different substances. So with gases, gases still have density, even though we think of them as like lighter than air and they're invisible to us, they still have density. So in general, if you remember from way back at the very beginning of the school year, we talked about how everything is made up of these atoms, these particles, and the state they're in depends on how fast that they are moving, which is, we call that kinetic energy. So kinetic just means like movement and motion. Gases tend to have a lot of kinetic energy. Their particles tend to be moving pretty fast all around. And kinetic energy is related to temperature. The hotter that a substance gets, the more energy it has, and the faster those particles move around. So when it comes to gases, the greater the temperature, the greater the kinetic energy that they have, their volume actually goes up. So when gases are moving around faster and faster, they're actually spreading out and taking up more volume. And as we just talked about, and as we just saw, volume is on the bottom of your density equation, right? It goes on the bottom of your division. So if that volume number gets bigger and bigger and bigger, then your density gets smaller and smaller and smaller, or lower and lower. Right? So the faster the particles are moving, the less dense that the air is. The slower that they're moving, the more dense the air is. So that is why cold air is actually more dense than warm air. As air gets warmer, its density goes down, and as air gets colder, its density goes up. So this is the reason why things like hot air balloons work, right? A hot air balloon is not made by pumping a whole bunch of helium into the balloon and letting that float you around. Instead, what they do is they heat up the air inside of the balloon. So as the air inside the balloon gets hotter, it becomes less dense and it starts to rise above the cooler air that is around it. Liquids also have different densities depending on the liquids. There are a couple different things that can affect the densities of liquids. Much like air, colder water tends to sink to the bottom of a liquid area. The warmer water tends to rise to the top. And if there are more things dissolved in your liquids, if you have a whole bunch of particles mixed in your liquid, that makes it more dense, right? You have more compactness, you have more stuff in your liquid. So like ocean water is more dense than salt water, or than, fresh water. Because ocean water, salt water, has all of that extra salt that is dissolved in it. And all that extra salt, in addition to the water, makes that more dense, more compact than just normal fresh water. And if you mix substances with different densities together, they tend to separate out with the denser layers on the bottom and the less dense layers on top. So here we have some sort of dark liquid, maybe like motor oil or something like that. And then some type of clear liquid, maybe like salt water or maybe a vinegar or something like that. And then some type of cooking oil or something like that on top here. So these are 3 different liquids with 3 different densities. And so because of that, they tend to settle out in these different layers than one another, with the less dense liquids floating up to the top and the more dense liquids settling down on the bottom. All right, so like I said, everything has density, whether it's a metal or a non-metal, or a liquid or a solid. And the density of the object, not the state that it is in, determines what will float on what. So mercury is a really cool element. It's one of the few metals that is liquid at room temperature. So what's being poured into this glass here, this is not water that's being dumped out, but this is liquid mercury. So a liquid metal. And mercury has a density of 13,600 kilograms per meters cubed. So that would be like, I don't know, 13.6 grams per centimeter cubed. So pretty dense material. Most metals tend to be fairly dense, as you might imagine. Lead, so like the stuff that they put in the X-ray tech vest so that you don't get too much radiation, or it used to be mixed into a whole bunch of things like paint and gasoline until they figured out that it's actually very bad for you. But lead tends to be solid at room temperature, a solid piece of material. And it has a density of 11,340. So if I took a lead ball and I dropped it into a pool of liquid mercury, do you think that the lead would float on top, or kind of sit around the middle, or sink to the bottom of the mercury? What do you think the lead ball is going to do when we drop it in liquid mercury? All right, Shannon says sit in the middle. Any other guesses?
I think the lead will be on top.
Ruben says it's going to be on top. All right, any other thoughts? Any other guesses? Top, middle, or bottom of the lead on the mercury? Nobody else wants to guess? All right. Well, Mr. Rubin, you are actually correct. And it's all because of these numbers right here. So lead has a lower density than mercury. And so that means that even if you have a solid chunk of lead and drop it into liquid mercury, it's still going to float. It's still going to sit on the top of the mercury. The mercury is more dense than the lead, so the lead won't sink down. It'll sit on top of the mercury, even though this one is a solid and this one is a liquid. That doesn't matter as much as the fact that their densities are so different. So solids are obviously tend to be fairly dense pieces of material. Depending on the solid that you have, they all have different levels of density. So the density of a piece of matter depends on what it is made out of. What are the different particles that make it up? One of the cool things, one of the kind of unique things about solid density is in everybody's favorite liquid, water. So for most things, when they become solid, their density goes up because their particles cram together and become very compact. Water is one of the few substances that actually gets less dense when it is solid ice. So this is the reason why in the wintertime in places in Michigan and Minnesota and stuff like that, lakes and ponds will get the ice forming across the top of the lake and not freezing down at the bottom. This is why icebergs and ice shelves are able to float in the ocean. This is why the ice in your glass or the ice in my water cup sits at the top instead of sinking down to the bottom. Even though they're both made out of water, the way that the water crystallizes together to make solid ice actually gives it a little bit more space. It becomes a little bit less compact, a little bit less dense. So we end up with solid ice is actually less dense than liquid water. It's one of the few substances in nature where the solid is less dense than the liquid. Again, that is why icebergs will float. It is because even though they're huge and they weigh millions of pounds sometimes, the ice that makes them up is less dense than the water that they are floating in. So there are a couple different things that can affect the density of your substance. Temperature is one that we talked about already. So as gases and liquids get hotter, they tend to become less dense and rise. And as they get cooler, they tend to become more dense and sink. Pressure can also affect density. So you can increase your density by putting your contents under a lot of pressure. So if you have like a pressure cooker at home, like one of those Instant Pots, I know my wife and I got one for a wedding present a couple years ago when we got married. And we don't use it like all the time, but we use it at least a couple times a month, I would say. And pressure cooking works by you seal off the inside of the cooker, and it's like totally airproof. And then you boil or you steam something in there. And as all of that gas and liquid gets hotter and hotter and hotter, it takes up more space, but there's nowhere for it to go. It can't escape out the top. So instead, it just builds up the pressure. It builds up the density of the air, essentially, inside of the cooker. And that is what actually cooks your food faster. That's what gives it that extra, that's what cuts down on the cooking time of different material, is because you increase the pressure inside of that container, all by making the water and the gas hotter, but without giving it any way to expand to. And then again, like we talked about earlier, when you have things that are dissolved in your liquid, that'll up the density. So like ocean water, or in places like salt flats, like over here, this person is actually mining, well, not really mining, but is cultivating the salt from these liquid pools. And so as you increase the amount of salt and stuff that is dissolved in your water, you increase its density. There's actually a famous sea over in kind of the Middle East, Eastern Europe area called the Dead Sea. And the Dead Sea is named that because nothing lives in it. And the reason nothing lives in it is because the water is extremely salty. There's even more salt dissolved in it than like normal ocean water. Because of this, people really like to go and swim there because you bob right on top of the water. The water is so dense that it's super easy to float right on the surface. Much easier than it would be in like your buddy's pool or even in something like the ocean. So the more stuff you have dissolved in your liquid, the more dense that it's going to be. All right, so here I have a little table of different densities of objects. And one of the other cool things about water is that water, pure water, has a density of exactly 1. Totally pure water is exactly 1.0000 grams per centimeters cubed. And so I'm going to have you guys help me out here for a little bit. So here we have different substances with their densities labeled out. And so for each one of these, I want you to tell me, is this substance going to sink or float if we drop it into water? So like this first one here, for example, air, obviously extremely low density. Air is a gas made up of oxygen and nitrogen and stuff like that. And it has a density of 0.0013. So that is a very small number, much smaller than water. So air is obviously going to float if you put it in water, right? Bubbles always rise up to the top of your substance. That's why as soon as you like pop open that can of Coke, you can hear all the bubbles and all of that bottled up carbon dioxide escaping and coming up and bubbling to the top. So that air floats to the top of the water. All right, so I'm going to have you guys help me out with some of these next ones. So wood, like, I don't know, let's say, pretty normal wood around here, has a density of 0.85. So if you pick up a big chunk of oak and toss it into a pond, is it going to float or is it going to sink?
Float.
It's going to float. Exactly. Wood has a density of 0.85, and that is smaller than the density of water. And so things with smaller densities float to the surface. So that is why wood tends to float, why you see like sticks and leaves and stuff like that floating on the surface of a river or a lake. And it's because most wood is less dense than water. All right, up next we have ice, which has a density of 0.93. So somebody other than Mr. Bueno, will ice float or sink if you drop it into water?
Would it float?
Float, exactly. Ice has a density of 0.93, and that is smaller than 1. And like we were just saying, ice is one of those few substances that even though it's solid water, its density is a little bit lower. Again, that's why ice will always float in your water or your Coke or whatever it is that you're drinking. So ice will float when you drop it into water. All right, aluminum is a pretty light metal. It's what most like soda cans and stuff are made out of. And aluminum has a density of 2.7. So if you take a ball of aluminum foil and toss it into some water, will aluminum float or sink in water?
Float.
Not quite. Remember, aluminum is 2.7. Water is 1. So if aluminum is more dense, what is it going to do in water?
It's gonna sink.
There you go. So 2.7 is bigger than 1. So aluminum will sink when you put it in water. Now I know sometimes you can see like soda cans and stuff that are floating on the top of the water. That has to do more with their shape than the fact that they are made out of aluminum. They act kind of like little boats. But as soon as water starts to go in to the soda can, then it'll sink down to the bottom, right? If you fill it up and then drop it into the water, it will sink. All right, lead is a little bit heftier than aluminum. Lead has got a density of 11.3. So is lead, if you think a ball of lead and drop it into water, is lead going to float or sink in our water?
Sink.
Exactly. Lead is pretty dense. 11.3 is obviously a lot bigger than 1. So lead will sink if you place it into water. All right, very nice, very nice. These other ones are, well, gold, again, pretty obvious. Gold is even more dense than lead. Gold is a very dense metal. So if for whatever reason you drop some gold into the water, like say a wedding ring or a class ring or something like that is made out of gold, and you drop it into water, unfortunately, it is going to sink. Gold is a fairly dense metal. So these other guys at the bottom of the density table here are 2 different types of alcohol. We have ethanol, which is the type of alcohol that goes into our drinks. So like beer and wine and whiskey and tequila and vodka, the alcohol that is in there, it's scientifically called ethanol. And then there's also methanol, which is a type of alcohol used in certain types of fuel. So ethanol and methanol are both less dense than water, right? They're liquids, but they're less dense than water. So both of these guys will float if you put them on water. So this is why, if you've ever seen like a flaming shot done at a bar somewhere, they usually have like the normal little cocktail that they made in the shot glass, and then they add in some extremely high alcohol like Everclear or Bacardi 151 or something that goes on top. And that stuff is less dense than a lot of the other mixers and stuff that went into the drink. So it will float on the top of the shot. And that is what the bartender is actually lighting on fire. So because it has a little bit lower density than water, it will actually float on the top of water if you don't mix it together. And so that's how they're able to do like flaming shots and stuff at bars, is by putting a little bit of near pure ethanol on top of whatever shot it is that you're gonna take. So in general, that is how density works when you're comparing these different substances. It's this ratio between mass and volume, and it can tell you when 2 different substances are mixed or combined in some way, which one is more likely to sink to the bottom and which one is more likely to float on top. All right. Does anybody have any more questions on what density is or how to calculate density, mass, or volume, or how the densities of different objects are related.
No questions.
What about mercury? How heavy is mercury?
Mercury is in between lead and gold. I think mercury is like 13.6, I want to say. So it would fall like right in here in this chart that we're looking at. So mercury also, even though at room temperature, mercury is liquid, it still is a very dense material. It's still a very dense metal. You can actually see some cool videos online, if you ever look it up, of people putting stuff into mercury to watch it float. Like there's one I saw a while ago where somebody had like a big like iron anvil, like the type that you see in like a blacksmith shop or like in cartoons and stuff that get dropped on people's heads. That is usually made out of iron, which has a little bit lower density, but they're super heavy. Even like a small one is a couple 100 pounds. So this guy picks it up and drops it into this big pool of liquid mercury. And you see this anvil just kind of bobbing and floating on the top of the mercury. And again, it's all because of density. It's all because of the fact that the iron, I feel like iron is usually what's in anvils, maybe a little bit of lead. But the iron and the lead are not as dense as the mercury itself. And so because they're not as dense, even though they're solid and the mercury is liquid, they still float on top. So the mass of something or the state of something doesn't necessarily determine if it's going to float. It mainly depends on its density. Great question. Any other density or density equation related questions? Righty. So your daily assignments for today and tomorrow, both pretty straightforward. They both have to do with calculating density. So for this first one on here, it starts off with a little bit of an example just to kind of help remind you of the density equals mass divided by volume equation. And so the first couple problems are just having you do that. It gives you the mass and volume of a loaf of bread and wants you to calculate the density. It gives you the mass and volume of a piece of wood and it wants you to calculate the density. Number 3 switches it up a little bit. It wants to know the mass, so it gives you the density and the volume of the material. And I included a helpful hint here for what your mass equation should look like. And then number 4 also changes it up a little bit. Number 4 wants to know the volume of the ball. And so it gives you the mass and the density of lead. And so again, I give you a little hint of what the volume equation looks like to figure out if you have mass and density. And then number 5 and number 6 actually go together. They're kind of linked questions. So they're asking about this rectangular block of unknown origin. It gives you the dimensions of the block. So it doesn't give you the volume directly, but it gives you the dimensions. And it gives you the mass. So the first thing that I want you to do is calculate the volume of the block. And when you have dimensions like this, all you have to do to calculate volume is multiply them all together. Width times height times length. So once you figure out the volume and you put your volume answer in here, You're then going to use the volume that you calculated plus the mass of the block from question number 5 and figure out what the density of the block is. So for number 6, you'll use the information from number 5, the mass that it gives you, and the volume that you have to calculate in order to answer what the density will be. So again, all very straightforward. Should be able to do pretty easily with some very simple calculations. The next one, very similar questions, although it ups the difficulty a little bit by trying to ask the questions in different ways and not giving you nice round numbers to deal with. Now we might have some decimal points that we have to look at. But first several questions, same exact thing. It gives you the volume and it gives you, the mass. It wants to know density. It gives you the mass. It gives you the volume. It wants to know density. Number 3 for Friday's homework gives you the density and gives you the volume and wants you to calculate the, oh man, even I screwed up there. So again, you have to read carefully on these questions. So it tells you what the density is, and then it asks, what is the volume if your mass is this? So again, on these questions, make sure to read the question carefully and figure out what is it that you're solving for. So what is it that you're calculating, and what numbers are you going to be working with? So again, you get density, and it asks you to calculate the mass if this is the volume. And then number 5 is a little bit different. Number 5, again, it gives you the density of silver and the density of aluminum. And then says, if you have this size container of a metal that has a mass of 21.6 grams, is this metal aluminum or is it silver? So you'll calculate the volume and you'll use that with the mass to calculate the density. And then you'll see, is that most similar to aluminum's density or is it most similar to silver's density? And that's what you're answering in these questions down here. So again, all these questions are doing is having you use 2 numbers in order to calculate a third number. What is up to you to figure out is what exactly is the equation that I need and how am I supposed to set it up? So most of the questions on today's homework are pretty straightforward, but Friday's homework, make sure that you read the questions carefully and are doing the calculations in the right order. Probably the thing that I see happen most often with these questions that students get wrong is that they got the numbers right, but they switched them around and they did volume divided by mass, or they did density divided by mass when it was supposed to be the other way around. So make sure you figure out what is your mass and what is your volume, and then you'll always put the mass first, mass divided by volume or mass divided by density, if that is what you're calculating. So both of these are pretty short, only 5 or 6 questions long. But that is what your daily assignments for today and for Friday, tomorrow, are going to look like. All right. Does anybody have any questions on today's assignment, tomorrow's assignment, or any final density questions that you recently thought of?